These are the frequently asked questions for pre-calculus for section 4383. And in exercises 49 to 52, it says evaluate by using the period of the function. And tangent is a function, remember, that has a period of 1 pi. So it just keeps repeating for every pi. So it doesn't matter what this number is in front of pi. What matters is that it is 1 whole pi. And between each one of these tangent graphs of this function, we have 1 period of pi. So whatever it is for the first one, whatever the tangent of 1,234,567 pi is going to equal exactly the same thing as the tangent of 7,654,321 pi. You need to think of it as a y coordinate. I mean, that's what's really going on here. So when you take the tangent of pi, no matter how many pi you're talking about, and you subtract the tangent of pi, you're going to get 0, because they will always land in the same spot when we're talking about periods of 1 pi. They're landing in exactly the same spot. Number 55 says light is refracted or bent as it passes through glass. In the figure, theta 1 is the angle of incidence and theta 2 is the angle of refraction. The index of refraction is the constant mu that satisfies the equation. The sine of theta 1 equals mu sine of theta 2. And they give us theta 1 and theta 2. So what I would want to do is solve for mu. And remember, these are just numbers. When we take the sine of theta 1 and the sine of theta 2, that's just going to be numbers. So the sine of 83 degrees over the sine of 36 degrees is what we're looking for. So I would double check, if you didn't get the right answer on this one, that you had your calculator set in degrees. Because if we punch this in, the sine of 83 degrees, parentheses, don't forget to finish that off, divided by the sine of 36 degrees, parentheses, we get 1.6886, so 1.689, and then, what were we looking for here? The index of refraction. So our label on that one should just be a number. And the book went, I was just checking here, they only went to hundredths on this one and did 1.69, but we'll leave that. Because again, degrees divided by degrees, that is just going to cancel out. And it's not really degrees anyway, because we are finding the sine of those two. So there isn't a label when you're talking about what's going on with sine, cosine, and tangent, because you're really talking about two side lengths dividing each other, since it's the ratio of two sides. Number 59, an F-15 aircraft. There, see, there's my best plane right there. At an altitude of 8,000 feet. Flies directly over a group of vacationers. And the vacationers are at an angle, not an angle, they are at a 7,400 feet. So that's their altitude, is 7,400 feet. All right, let me get my right angle here in the right position. And it says, find the distance d, if we just call this angle theta right here. Find the distance d from the group to the jet at the given angle. Well, there's d. First thing I notice here is, I'm not going to label this 8,000 because that was 8,000 all the way down to the ground. So we need 8,000 minus 7,400. And that gives us 600. And this was in feet. So to set this up, we have opposite and hypotenuse. That's going to be sine. So the sine of theta equals 600 over d, but what we're really trying to find is d. So let's multiply both sides by d, and then divide by the sine of theta. All right, and all three of these are in degrees. So it would just be a matter of punching them in, but you know, like the first one, we have the 45-degree angle. I would much prefer that you set up your little triangle and say, okay, what's the sine of that? Well, opposite over hypotenuse is going to be 1 over the square root of 2, which is the square root of 2 over 2. And punch that in. And quadrantal angle there of 90, some good practice on that would be to remember that this is 0, 1, and r is 1. So the sine of 90 degrees is going to be y over r, which will be 1 over 1, and that will be a 1. So for B, we will have 600 divided by 1, which is, of course, just 600 feet. And the 140, yeah, you'll use your calculator for that one. So for C, we would take 600 and divide it by the sine of 140 degrees and crank this stuff out on your calculator. So let me get the answer to A here. 600 divided by parentheses, square root of 2, parentheses, divided by 2, parentheses, and that is 848.528 feet. And then 600 divided by the sine of 140 is 933.434 feet for that one. So they're just changing that angle of elevation as you go through each one of those problems, but it's the same setup, it's the same formula because we still are trying to find the distance as we go through there. All right, next one on your list, 61. If theta is an angle of a triangle such that the cosine of theta is less than 0, all right? So I'm thinking about my Cartesian coordinate plane and the sines. So that I can see where would cosine be less than 0. And cosine being less than 0 would be in quadrant 2 or quadrant 3. And it says if theta is an angle of a triangle such that the cosine of theta is less than 0, then theta is obtuse. Justify your answer. Well, obtuse means that we are greater than 90 degrees. So obtuse angles are greater than 90 degrees. And we know that cosine is less than 0 in second and third quadrant. That look more like a Q. Therefore, the angle must be, so therefore theta must be obtuse. I mean, it just follows from the drawing that I have up there. We know that the only way to get a negative cosine is going to be in quadrant 2 and quadrant 3. And obtuse angles are going to be greater than 90 degrees, and that's what's going on in quadrant 2 and quadrant 3. That terminal side will open to give us an angle bigger than 90 degrees. 7 to 70, we want a value of a unique real number, theta, between 0 and 2 pi. So that means we're supposed to use radians here. And right away when I saw the 1/2, I'm thinking about the fact that my 30, 60, 90 triangle has those numbers. And I just need to figure out which angle I'd be talking about that would get me a 1/2 for a sine, and that's opposite over hypotenuse for 30 degrees. So we're talking about 30 degrees, but they want tangent to be negative. So it could be that the 30 degrees is just going to be my reference angle that I need for this. So I have plus, plus, plus. I know it's not in first quadrant, so it's not 30 degrees. Plus, minus, minus. Definitely going to get a tangent there that would be negative. And another one over there in fourth quadrant would have tangent negative as well. So if my sine is going to be a positive 1/2, I notice that what I have to have in order for all of this to work is my sine values must be positive and my tangent values must be negative. And that is happening in quadrant 2 because this was a positive 1/2. That means it must be a positive sign, but my tangent must be negative. So my 30-degree angle would be my reference angle, and I think about the fact that, well, the rest of this is how we would measure the angle, having that initial side. So 180 minus 30 would be 150 degrees, or you can think, all right, this is 1 pi. If I divide it into 30 degrees, that's going to be 6 chunks, and this is just 1 out of those 6. So this would be 5 pi over 6. That is the only way that's going to happen. Cosine for number 68, again, same type of thinking where I'm thinking it has to be a 30, 60, 90 triangle here because I need my cosine to be the square root of 3 over 2. And again, it has to be 30 degrees because we'd have adjacent over hypotenuse. So we're looking at 30 degrees, but my cosine has to be positive and my sine needs to be negative. So I need to have cosine positive and I need to have sine be negative. And that is only going to happen in 4th quadrant. So then I think for that reference angle to be 30 degrees, I am again talking about an angle that I need to have. So the 30 degrees again gets me thinking there are 6 30-degree chunks, and to get 2 pi, that would be 12 pi over 6. But one of those has to be left over because this is pi over 6 as 30 degrees. So that brings me to 11 pi over 6. Now you could certainly just figure out what these are in degrees and then convert them. But I'm going to try and explain all of these so that you start thinking in terms of pi, in terms of all of those radians that we have. 69 says the tangent of theta needs to be -1 and the sine of theta has to be less than 0. So if the tangent of theta is going to be -1 and sine is going to be negative, sine and tangent have to be negative. So I think, well, where would we get sine and tangent to both be negative? And that is going to be in 4th quadrant. And then another interesting fact about this is that it has to come out to 1. So I think about my little 45, 45, 90 triangle and realize that's where I would get a 1. Tangent opposite over adjacent for 45 degrees, that would give me the 1. So this is 45 degrees for a reference angle, but it's 45 degrees in the 4th quadrant. So what I'm really doing is I'm taking that 2 pi and I'm subtracting 45 degrees. But remember that our 2 pi, if we're talking 45 degrees, is in fourths. So that would be 8 pi over 4, but I need to subtract 1 pi over 4. So that would give me 7 pi over 4. And again, you could figure out what it is in degrees and then you could go ahead and convert it. Number 70, we have the sine of theta being the square root of 2 over 2, but it's negative square root of 2 over 2, and tangent has to be positive. Well, this is from my 45, 45, 90, and remember this will be 1 over the square root of 2. So I need my opposite to be a 1, and I need my hypotenuse to be the square root of 2. Well, it's 45 degrees again, so it's just a matter of where. You know, where is this 45 degrees going to go? So now, we know that we need sine negative and tangent positive, and that happens in quadrant 3. So we need quadrant 3 to give us a reference angle of 45 degrees. And we know that all the way across is pi, and we know that 45 is pi over 4. So pi is the same thing as 4 pi over 4. 4 pi over 4 plus 1 pi over 4 would be 5 pi over 4. All of those very, very good visual problems for 67 to 70.